All right, let's talk about one of the most unsettling ideas in all of physics. It's the possibility that our entire universe is fundamentally unstable. That everything we see, everything we know, is basically built on a foundation that could just crumble at any moment with absolutely zero warning.
The universe could end right now, and we wouldn't even see it coming. Now look, that is not a line from some sci-fi movie. It's a genuinely chilling prospect that comes straight from our best understanding of particle physics. It describes a cosmic event that wouldn't just destroy things, it would completely rewrite reality itself.
So, the big question is, how? How could something like that possibly happen? How could the entire universe just stop? Well, to figure that out, we need to become cosmic detectives. We're going to investigate the very fabric of space and the fundamental particles that make our world what it is. This potential glitch in the cosmos, this ultimate doomsday scenario, actually has a name. It's called false vacuum decay. And it suggests that the stable, predictable universe we think we live in might just be a temporary illusion.
Okay, to really understand this threat, we have to start by examining the scene of the crime, so to speak, the vacuum of space. Because it turns out, what we all call empty space is, well, it's anything but empty.
Yeah, our whole idea of what a vacuum is has totally changed. Back in the day, we thought of it as just nothing, a boring, empty stage for things to happen on. But then quantum field theory came along and completely blew that idea out of the water. It revealed that what looks like empty space is actually this bustling, fizzing sea of quantum fields, all humming with energy. It's not a backdrop, it's a dynamic, active part of the universe.
Now, in this quantum world, all those fields want to settle into their lowest possible energy state. You can think of it like a ball rolling down a hill. It always wants to find the lowest point. A true vacuum is that absolute lowest point. It's the ball sitting at the bottom to the deepest value you can imagine. Once it's there, it is perfectly stable. It's not going anywhere.
But what if that ball doesn't quite make it all the way to the bottom? What if you get stuck in a little dip on the side of the hill? That right there is a false vacuum. It feels stable. Sure, it's not rolling around, but it's not in the true lowest energy state. There's a much deeper, much more stable valley just over the next ridge. And here's the kicker. Our universe might be in exactly that kind of precarious spot.
So, who's the main suspect in this whole cosmic drama? Well, it's a field you've definitely heard of, the Higgs Field. This is the thing that permeates all of space and gives fundamental particles their mass. And scientists have a sneaking suspicion that this all-important Higgs field might be the very thing that's just resting in a false vacuum.
If the Higgs field is unstable, here's how the disaster would play out. First, thanks to a seriously weird quantum effect called tunneling, a tiny bubble of the true vacuum could just pop into existence anywhere, at any time. Then, that bubble would start expanding outward in all directions. At the speed of light, there'd be no warning. And third, inside that expanding bubble, reality itself would be rewritten. The laws of physics, particle masses, the forces that hold atoms together, poof, all of it changed in an instant.
This all sounds like something out of a comic book, right? But here's the thing. Ever since we discovered the Higgs boson, we can actually test this idea with real data. So let's put our universe on trial and take a look at the evidence the physicists have collected.
This idea has actually been kicking around for decades. The math was first worked out way back in 1977. But for a long time, it was just a spooky theory. The real game changer was in 2012, when the Higgs boson was finally discovered at CERN. That discovery gave scientists the last crucial piece of data they needed to actually run the numbers.
And it really all comes down to two key pieces of evidence: the mass of the Higgs boson itself and the mass of another particle called the top quark. You can think of these two numbers as being in a cosmic tug-of-war that shapes our energy landscape. The Higgs mass kind of props the valley up, while the super-heavy top quark tries to pull it down, making it less stable. The delicate balance between these two numbers tells us everything. Are we in a deep, safe valley, or a shallow, dangerous dip?
So, what's the verdict? When you plug those measured masses into our best theory of particle physics, the Standard Model, the conclusion is, well, it's chilling. The math says our universe is metastable. That's the scientific way of saying it's stable for now, but not forever. We appear to be living in a false vacuum.
Okay, before you start panicking and building a bunker, the trial isn't over yet. There's some really compelling reasons to doubt this verdict. There are reasons for what you might call cosmic hope.
So, seriously, should we panic? The short answer is
Probably not. The case for our universe's imminent doom actually has some pretty big holes in it. Let's hear the defense.
First off, that scary verdict, it's based only on the standard model of particle physics, and we know for a fact that theory is incomplete. It doesn't include gravity, or dark matter, or dark energy. It's entirely possible that new physics, maybe something like supersymmetry, could introduce new particles that completely stabilize the vacuum. And honestly, the most compelling evidence we have is just looking around. Our universe has been happily existing for 13.8 billion years. If it were truly fragile, it probably would have decayed a long, long time ago. In fact, when you run the numbers, the calculated lifetime of our vacuum, even in this metastable state, is trillions upon trillions of years, way, way longer than the current age of the universe.
So where does all this leave us? Well, the truth is, the jury is still out. We just don't have the final chapter of this cosmic story yet. The real answer is waiting for us in some future discovery, something that takes us beyond the physics we know today.
And you know, maybe that's the real point here. This terrifying possibility isn't just some cosmic horror story. It's an incredibly powerful motivator. It's one of the things that drives scientists to search for a more complete theory of everything, a theory that will finally tell us the true nature of our reality and the ultimate fate of our universe.
It really leaves us with this one profound final thought. The very fact that we are here, that you and I can even think about these questions, proves that our universe is stable enough for life to arise and evolve. But the ultimate question remains, is enough the same as forever? That's a question only the future of physics can answer.